Hello. Am I audible, Sonal? You there?
Yes, Adarsh, you are audible.
Okay. So, good afternoon, everyone. Welcome to the session. So we'll go ahead with the session in some time. Let's some more participants join. By then, just wanted to know the same thing the same question that I had in the last session. It is about the number of lectures you have watched, or have you done with the questions, attempted questions?
Yes, sir. Sir, actually, I have a conceptual doubt.
Okay.
I posted in the chat, but I guess you joined a little late, so I'm sending the same text again.
Okay, so it is about the component building, Python. Python was a concept of by itself. It was a concept by itself. It is not doing anything with the JS. So it was taken as an alternative to JS. I'm not sure how well it worked, but it was taken as an alternative to JS. No conversion there.
Okay, all right.
Okay, concept of it, component building. Okay, what about it?
I just don't understand how exactly and what exactly do we do with component building.
Okay. See, I'm not very, sure what component are we talking about here. Can you please elaborate a bit more?
This came in context with DOM, document object model. Sir mentioned
Okay,
this
all
in
right.
the
Okay, so DOM and then the components of DOM, is it like something like that?
yes.
Okay, no, see, something, it is like a perspective of understanding with what we say. It is a perspective understanding. Let me explain you this, what I'm trying to say. So let's say there is something, content that is written in text. Okay. So the content is written in text and you can understand it because you understand how to read the text. Okay. But, and there is, now we are talking about a machine, right? So we have all the entire concept of ones and zeros because we cannot directly explain things to a machine by whatever we say, right? Everything needs to be converted into digital system, and then depends on what language machine understand, it will be converted to that. Okay. So now we'll talk about HTML. Okay, so if you see an HTML file, you understand HTML file because you understand HTML. Okay, what are you basically understanding? The text. Okay. If you see that in the response, you might see that it is a text / HTML. Okay,
Yes.
so whenever you see the response of a browser for any web page, you will see it is a text / HTML. Why? Because two things. The text is for the user, human. Okay, and the HTML is for the browser. The browser by itself does not understand what the text means. But if it looks as look at the text itself, it will see that there are some tags, and then it behaves according to those tags. Okay, so that is a text / HTML. So this is about the HTML. Now comes JavaScript. JavaScript does not understand HTML. Now you are understanding text. Browser is understanding HTML. What about JavaScript? How will it target things? Okay, so there comes the concept of DOM. JavaScript understands objects. So now that now that your textual part is converted into certain tags, okay, which browser could understand, the tags or the entire structure. Now it is observed that the HTML has a structure. So why not convert it into something that is tree-like structure where you can call every every change of branch as a node, call it as an object, which will make it easier for JavaScript to understand. Okay, so here the client is client as in not the client server client. Here the person who's using that part of information is changing. When it was a human, you call it text. When it was browser, you call it HTML. When it was JavaScript, you call it DOM.
All right. So the component building part is basically making changes to the DOM.
Yes, you might want to add something, update something.
Okay.
Right, so that is so what is actually happening, everything is getting modified. For you, the textual part is getting modified. For browser, the HTML is getting modified. For JavaScript, the components or the objects are getting modified.
All right. Thank you.
Okay, so that is where we talk about component building. So this is what, if I've understood your question well, whatever I have said is the answer to that.
Yeah, I guess I now understand the whole concept of it. Thank you so much.
Okay. Okay, and about Brighton, it was taken as an alternative. I cannot talk about it in detail because I even don't know, and that is the reason we can say that it could not did not work well. Right, JavaScript was better.
Okay. I mean, I just was not sure whether we run directly the Python code or do we convert it to JavaScript or something.
Okay. Yeah. So this Python has a tendency to put its hands on everything. So not insulting Python, but see, there is every module, for everything there is a module in Python. So maybe why not for web dynamicity in web? So maybe the concept from Python comes from there.
Mm-hmm. Okay, cool. Thank you.
How do you create a DOM model? Like, what software do you use to create that?
We don't generally create a DOM. It is that's what it is, a representation which JavaScript understands. So our browser does that. Okay, you create HTML because you understand the text. You create HTML. Okay, so that HTML you take it as a part of text. Browser understand it as an HTML, and then that HTML is converted into DOM by the browser itself. So the JavaScript should understand.
Okay.
Okay, so if I so whatever, so if I write something, it will be same thing what I'm saying now. Just give me okay, so I'll write let's say this is okay, so this is a part of text. Okay, so this is your text, whatever you have understood, because you're writing HTML, but for you it is a text. Okay, for browser this text is HTML. Okay, and then the same browser converts this HTML to blocks of pieces. Okay, nodes and branches. Okay, so this is DOM. Now if you want to make changes in your HTML by not touching the HTML, by not touching, I mean by not making changes anything here, but from here you the system should know what to target and how to target. Okay, that is the reason we have DOM. So is this part clear?
Yes, sir.
Okay, so there can be a lot more detail that we can talk on DOM, but I guess for understanding what exactly the DOM is doing, this is sufficient. All right. No, so now we also so there is a scope to what we do, like we target certain elements. Okay, but uh, apart from DOM, there are other things like window. Okay, so this takes care of not only the document but also the window on which this document is running. Okay, so there are hierarchy. So if you see that there is document, and then so there is document, right? Then there is HTML. Then HTML has head, body. Okay, but what about this? So there is a window. Okay, so there's some internal application or some internal things can also be accessed by the help of window. So our scope is to understand from document and forward. All right.
Yes, sir.
Okay, so all right, yeah. So so in the last solve with instructor session, so if I'm not talking about the Flask SQL alchemy because it was the last part of the entire application that you have created. But if we go with the content, we talk about week 6 content, that is about the APIs, right? So I guess even I was watching that video, so I guess it was covered in quite detail, and all the aspects that were required were covered in quite detail, right? So I talk about creating API, and then um, uh, what we say, creating the type of output you want, okay, and things like that. So we have done with Postman and all, testing the API. So anything that is there that is not clear from that part? So I guess everything is clear in the API, right? Okay. So the thing is, in the today's session, what I was thinking to move aside and work with, do not work with code, but we'll talk about certain numericals. Okay. So these numericals may be familiar to you, familiar as in you may have seen them in practice and graded. So I'm basically covering the numericals from week 8 and week 7. Okay, and this will give you good idea in solving the questions that might come in quiz. Okay, so again, the idea would be to get the basic concepts, and the questions that come in quiz may or may not be. If they are, they will be built upon whatever we are learning today. Okay, and also the concept that we have done in week 1. So numericals part is something what I'm thinking to take today instead of the coding. Okay. All right. So, yeah, somebody speaking.
No.
Okay. So, in general, solve with instructor, which is related to coding, what we do is we create a problem statement. Okay, and then I explain what we need to do. What is our target? All right, and then we start on coding, and then I start. All right. In the numerical part, if you all have attended the week 1 solve with instructor session, it's long back, 8 weeks before. So, if you can try solving it by yourself first. Okay, and type the answer in the chat directly. Okay, so if you see in the bottom right of the chat, you'll see that it is to everyone. Rather, what you can do is, my name is Adarsh, right? So you can send it to me. Okay, so yeah, so you will solve the question, find out an answer. Okay, based on what you came up with, and then send me that answer directly in the direct chat. Okay, this is basically done, it is not a test, it is basically to not influence you with others answers. All right, so we'll know that whatever are the possible answers, and then why one is right among them and why others are wrong. All right, so I hope this is clear, right? So if I'm presenting you a question, you will simply try to solve it, and then give the answer in the personal chat to me. Okay, just have to change this everyone to Adarsh Beauty probably. Okay, so the procedure is clear, right?
Yes, sir.
Okay, so I'll share my screen now. So I've created these questions on Jamboard. Just give me a minute. Okay, so is my screen visible?
Yes,
Yes.
sir.
Yes, sir.
Okay, so we have a set of 5 questions. Okay, Alex, and these questions are questions from your practice section of practice and graded section of week 7 and practice session of week 8. Okay, so this will help you and understand what the next set of numericals. Okay, you can start giving it a try. Okay, I'll wait for 2 to 3 minutes and then start solving. All right. Meanwhile, if there is anything that you don't understand, just let me know. By the way, I see there is comparatively less number of participants in this session. We generally have more than 60. So is there any other session going on? Does anybody have idea about that?
No, sir.
Okay, no other session going on. Okay, fine. People will come then. Okay, you can start solving and type answers in the chat. Personal. Okay, can't say a single answer. Why is that? Yes, answer can be wrong. No issues with that. Just give it a try. Okay, because then if you if you give it a try, you will understand what mistakes you made if it is wrong. If it is right, good. But if it is wrong, you'll understand what things to keep in mind when solving these type of questions. Okay, so an active participation from you all is mandatory in this session. I've got 2 responses out of 52 participants. Okay, 3. Okay, please note that the units that we want is gigabytes per second. Okay, so if you're not mentioning any unit, I'll consider it gigabytes. It is in gigabytes per second. Okay, saturation. Is this okay? Should I start?
Yes, sir.
Okay, so what I'll do is first I'll type the responses that I've got. Okay, there are a few, so I'll type the responses. Okay, okay, so one is 16 Gbps. Okay, one is 8. Okay, it's only 8, so I'm considering it Gbps. Okay, then there is 0.016 Gbps. Okay, and then we have 512. So not it is again no units. I'm considering it to be Gbps, and then 128. Same. Okay, no unit. All right. So, so while solving these type of questions, we first need to see what is happening here, right? So there is a RAM. Okay, there is a DRAM. So we may have seen heard about DRAM in the hierarchy, right? So it comes before after SRAM, right? So this DRAM, there is a DRAM. What it does is it has a burst width. So what is burst width actually? It is the number of parallel paths. Okay, number of parallel paths as in number of bits it can give at one shot. Okay, so it is number of bits it can give in one shot. So if I say that there is 64 bits. Okay, so before going to 64, let us do it with a smaller number, let's say 4. Okay, so we can say that there are 4 ports to it. Okay, and with one shot, whatever bit is there, let's say 0, 1, 1, 0, whatever bit is there, with one shot, all these bits get transferred. Okay, so the output I'll have 0, 1, 1, 0 at one shot. So if you relate this with 64 bit, it will come up with a parallel path, or the RAM having 64 such ports, and with one shot it will give 64 such bits parallelly, okay, in one go. Okay, so that is about the bus width. Okay, now next thing that we have is a clock speed. Why do we have clock speed? Okay, so if you have heard carefully, I was saying in one shot, in one go. What do I mean with shot? Okay, and what do I mean with go? So both are the same thing, but what is it actually? So the clock speed, before going to the clock speed, I'll go with the clock cycle. Okay, so there is something called as clock cycle. Okay, so this clock cycle is called as trigger, will be considered as trigger for this bus. Okay, it will be considered as a trigger. So with one shot or one go, what happens if I trigger it once? If I trigger it once, all 4 bits will be transferred. This is what it means, right? So if I write a bus width of 4, okay, and then it is giving me a bus width of 4, and then there is one trigger. What will happen with that trigger? As soon as that trigger initiates or that trigger hits, 4 bits of data will be transferred within that trigger. Okay, so this trigger is called as one clock cycle. Okay, now we have given a clock speed of 1 gigahertz. So what does this mean? In 1 second, there are 1 gigahertz, like, so 1 giga triggers or 1 giga cycles, right? So this is what it means. So in 1 second, how many times the clock will hit, or how many times the clock cycle will go? 1 giga times, right? So 1 giga as in it is 10 raised to power 9. Looks awkward while saying 1 giga times. You need to understand that it is 10 raised to power 9 times the clock will trigger itself within 1 second. So this is the meaning of clock speed of 1 gigahertz. Okay, so we are clear with bus width. We're clear with clock speed of 1 gigahertz, and then there is operating in DDR rate. So this is second thing that we need to understand. Okay, so in bracket also it is said that double data rate or two values per clock. Okay, so two values per clock, what it means, let's say it is 0 1 1 1 0 1 again, so 1 0 1 1 0 1 and again 1 0. So what happens with one clock cycle, with one trigger, it will not give 4, but it will give 4 into 2 8 output. Okay, 8 bits given within one trigger or one clock cycle. Okay, so this is the interpretation of what we are trying to understand from the question. Okay, so what is happening? So with this bus width, I will have 64 bits. Okay, with the DDR rate, it will be into 2. Okay, and we need to find out maximum bandwidth. What is bandwidth actually? It is number of bits per cycle, right? Number of bits per cycle. Obviously we need to represent the answer in gigabytes, but that is a conversion that we need to, that we will look at later. But what does maximum or bandwidth say? It says number of bits that can be transferred within 1 second. Okay, so here what was important to understand the clock speed, the number of clock cycles that we are getting in 1 second, so that we can convert this clock speed into the time. Okay, and then bits, that is the data. Okay, so simply we need to multiply. So this is the total data getting transferred with one clock cycle, and then we need to find out the number of clock cycles. Okay, so this is the total bandwidth. Okay, so it will be the data into, or the bits, number of bits, and then into the number of bits per second. Okay, so it will be bits per second. Now what remains is the conversion. Okay, so what do we need to convert it into? Gigabytes per second. So leave the per second as it is, and this 10 raised to power can be 9 can be easily converted into giga. So we have 128 giga bits per second. I need to convert it into bytes. Just simply divide it by 8. What we will get? 16 gigabytes per second. Okay. Now, so why this 8 is wrong? Probably we have not considered this factor. Okay. Why GBPS is wrong? Probably you have not converted it properly. Okay. I'm not sure why we are getting these two answers. Okay. But I hope those who have written these answers, they are clear with how are we getting this, right? So this part is clear. This question is clear.
Yes, sir.
Yes, sir.
Okay, so there is one message in chat. Okay. Okay, so those who had the answer 16 Gbps gigabytes per second is correct. So this part is clear. This first question is clear, right? Okay, we'll move to the next question. Okay, familiar, may have seen in the practice. Okay, so it's your turn. I'll just keep it shut for 2 minutes, 2 to 3 minutes, and I'm expecting answers in the chat. Okay, read the question carefully, try to understand what is happening. Okay. Should I wait for a minute? Is somebody in between the procedure? I'm getting responses. Okay, that's good. I'm getting responses. So and one good thing is there is no much variation in the responses. So there can be one correct and one wrong answer. So that is fine. Okay, so I'll go ahead. But for this, okay, so for those who gave the answer, that is okay, that is correct. Those who have given the correct answer, that is really good. Okay, but those who did not, just let me explain the scenario here. Okay, before that, I'll just give you what answers I'm getting. Okay, so okay, so it is okay. So one of the responses is 8.33 millisecond. Yes, m second is millisecond. Okay, that is millisecond, and the other is 0.12 millisecond. Okay, what is the relation between these two answers? Can anybody tell me? What can be the relation between these two answers?
I can guess, like uh, basically 120 is the revolutions per second, and then this might be like per millisecond that guy has calculated something. It's like 0.12, like uh, rotations per second, basically.
Okay, okay,
And the
yeah.
other thing is basically one time taken for one rotation.
Okay, okay, so that is one observation. Another observation is both are reciprocal of each other. Okay. Okay, so we'll get to that, what I'm trying to say here, but let me explain this question first. Okay, so for understanding what is happening in the question, just consider a scenario. I'll try to explain it with a real life example. Okay, uh, so consider that there is a train. Okay, there is a train here. Okay, and here I'm standing on a platform. This is the platform, and there is one train here. Now, this is a special train that runs only once a day. Okay, so consider like that it runs from this station, it runs at 8 a.m. in the morning. Okay, now by any chance, if you miss this train, you can only catch it the next morning at 8 a.m. same time. Okay, so if this train goes ahead, you will miss the train. Okay, and this train once went ahead, it cannot come back for you. Okay, it will not reverse itself for you. Okay, so once if I am here, if I'm sitting on the train at 8 a.m., if I am available on the platform at 8 a.m., then and then only I can catch the train. Okay, otherwise, even if I surpass 1 second more than 8 a.m., the train will move and I will not be able to board it. Okay, so for the next time to get board on the train, I will have to wait for one complete day. Okay, so that is, now if we try to relate this with what is happening in this question, we'll see that there is a magnetic disk. Okay, so I'll draw a magnetic disk, and let's say this is the length of the disk. Here, by the way, I hope this is visible. It's not very small, and it's not very detailed also. It's just an arrow looking downwards, which I'm calling it as a lens. Okay, and this is the disk. Okay, so it rotates this way. So this disk can spin only in one direction. Okay, so consider this disk to be the train, and it goes in only one direction. Okay, it cannot come back once it starts moving. Okay, and then there is certain speed which I'm not telling for this train because it is not relevant. But what I've said that there is a duration of 24 hours, that is one day. So if the train moves, the next time you can catch the train only on the next day on the same time. Okay, now if I relate this with the our question, that is I can take that information from here. Okay, it is 7200 revolutions per minute. Okay, so if I try to find out number of revolution per minute, uh, that is 7200. Okay, so I need to find out how much time does it take for one revolution? Okay, I just need to find out how much time for it takes for one revolution, because that will be analogous to 24 hours time of the train. Okay, so it rotates 7200 times revolution per minute. This means in 1 minute, how many rotations I'll get. Okay, not 61. Okay, so 1 minute, how many revolutions I'll get? If I try to find the answer of this, okay, so it is somewhere around 1.38 10 raised to power minus 4. So this is the time it takes for one revolution. Okay, same thing we'll find in second. Okay, but there is a time to that. So what is happening here? Let me just clear some part. Let it be. I'll draw it here. So what is happening? So this is my disk. Okay, and it is rotating, and this is my lens. Okay, let's say my data is here. Whatever I want to write, whatever I want to read from the disk, my data starts from here. Okay, so if this lens get activated at this instance, let's say t equals to 0, if at t equals to 0 this lens gets activated, I will be able to retrieve the data which is followed from here. It starts with here and it is spread along the disk in this direction. Okay, so this disk rotates this way. What will happen? This data will keep on rotating. So from here it will go till here, like this, right? So this data move ahead, and then the lens started reading the data one by one, bit by bit. Okay, so this is the procedure. Now what happens is, if this data moves ahead and then the lens getting activated. Okay, so if the lens gets activated at not 0, but let's say a time that is greater than 0, very small, but let's say it is greater than 0. Okay, so at that instant the lens will fail to retrieve the information. Okay, because it does not know the number of bits that went in the time that lens took to start. Are you getting this? Did you get this part?
Yes, sir.
Right, so what happened here? If by any chance the lens moves ahead a bit, I don't know how much. Okay, we cannot comprehend that how much it will move with the given information, but by any chance if it moves ahead and then the lens get activated, the lens will not be able to retrieve the information. When can lens be able to retrieve the information? When this thing goes the entire revolution and come back to this position. Okay, before that, no, not possible. All right, now this duration, why is this duration one revolution? Because I've taken very small time and I'm assuming that it has moved very minutely ahead. Okay, but doesn't matter if it had moved very minutely ahead, also the lens will not be able to retrieve. This is the idea. Okay, now if my data went till here and then the lens get activated, the data or the information receiving will be done after this part moving half a revolution. Okay, so this depends on how ahead the data went, okay, with the revolution. Okay, now what we are trying to find out, what is the worst case latency? What will be the worst case latency? What will be the scenario there where the data had to move the entire revolution, not the part of it. Okay, so for that we need to assume that the data has moved minutely ahead, and then the lens failed to retrieve the data, and then for now to again retrieve the data, it will have to wait for the disk to take the entire revolution. Okay, now that time which lens is taking, because see the lens got triggered at some point greater than 0, some point. Okay, but the information will receive only after the entire rotation, the time taken by entire disk to rotate and the data to come to the same position, right? So that duration is actually the latency. Okay, and why is it called worst case? Because it represents the entire revolution. Had it been a part of revolution, let's say half revolution, quarter revolution, 3/4 revolution, or any fraction, or any fraction of that sector, okay, in that case it wouldn't have been the worst case. Why is it the worst case in this case? Because it has to take the entire revolution. Okay, and there is no and there we cannot go more than one revolution, because more than one revolution means the lens is already retrieved the data, right? So the worst case latency would be the scenario where the data has moved minutely ahead, where the disk had to move the entire rotation, has to take the entire rotation to retrieve the data again. Okay, so this is the idea. So what do we need to find out? We need to just find out how much time in milliseconds the disk take to rotate in or disk take to get the one rotation or one revolution. That's it. Okay, so what I'll do here is I'll simply write 7200. It is rotations or revolutions per minute. Okay, then we'll easily find out the rotations or revolutions per second, right? So this is revolutions per second. Okay, so if you solve this is 120. So it takes 120 rotations per second. Okay, 120 rotations per second. So how much rotation or how much time it will take in seconds for one rotation? For one rotation, say this is the number of rotations, right? So for that, what we need to do is it is 120 rotations per second. We need to find out second for per rotation. This is what we need to find out. Okay, therefore we don't need to take this 120, we need to take 1 by 120. I hope this part is clear why we are taking seconds per rotation. Okay, because we are not interested in rotations taken in 1 second, we're interested in time taken for one rotation. So this is what it is representing, seconds for one rotation. Okay, so if I take the reciprocal of 120 or 1 by 120, I'll get 8.33. So it is 8.33 into 10 raised to power minus 3 seconds. Okay, because we have found out the rotation per second. So in reciprocating that,
Hello?
we'll get, yes.
Sir? Hello?
Yeah, tell me. Yeah, who's
Sir,
speaking?
yes, sir, Rakesh.
Yeah.
So 1 by 120, that is 8.33 into 10 power minus 3, right?
Yes.
Okay, sir, it's okay. Got it.
Yeah, so 8.33 into 10 raised to power minus 3 second. But what is 10 raised to power minus 3 second? It is 1 millisecond, right? Or millisecond. So the final answer is 8.33 millisecond. Okay. Now we'll talk about this answer. Okay. So if I'm taking 120 rotations in 1 second, we cannot simply divide it. We cannot simply make this second into milliseconds, right? Dividing it by 1000 will not give us the correct answer. Will only give us this number. Okay, this number has no meaning here. Okay, we need to. So therefore, whenever I solve numericals, you may have seen that, you may have observed that I give special attention to the units. Okay, I give special attention to units because that are quite intuitive to give me an idea of what to do next. Okay, what we want next. I had this, I wanted this. Okay, so simply inverted it, right? So finally you will get 8.33 millisecond. So what is happening here? The entire disk to rotate once, okay, from end to end to rotate once, it will take 8.33 millisecond. And in our case, that is the worst case latency, because we wanted to find out how much time the disk takes to rotate one revolution. Right? You got the idea, right? This question is clear. Any doubt in this question? Hello, I'm audible.
Yes, sir.
So
Yes, you're
what
audible.
exactly are we
Okay.
trying to find
Hmm.
over here?
So we are trying to
find the
find out the
latency,
worst
right?
case latency. Hmm.
Yeah, we are trying to find the latency in milliseconds, and we have just taken out seconds per rotation. How is that correlating? I'm not able to understand that.
Okay. See, seconds per rotation, right? So seconds per rotation is you what? How do you comprehend this? What does this mean? It is the time taken for this to rotate to get one rotation. Okay, the
Okay.
time taken by the disk to make one rotation. All right, that is the time. And in our case, the time taken by disk to make one rotation is the worst case latency. Okay, anyway, it is both the case, it is time. See, the number that comes in denominator has no meaning. Seconds per rotation is nothing but seconds.
Okay.
Um, should I explain this worst case latency with the rotation? Why is this worst case latency?
Yes.
See, what is happening? What is happening? See, are you clear that if by any chance, if I miss to retrieve the data at t equals to 0, I will have to wait the end. I'll have to wait for the data to come back to me, the entirely to come back to me, right? Okay, I cannot
Yes, that
miss
I understand.
certain starting bits and then say that, okay, this is my data,
Yeah, that I understand.
right? Right. Now, what is this t equals to 0? This is where the lens got activated. Okay. But will it retrieve data? Because will it retrieve data given the condition that the data has moved a bit ahead?
Okay. Yeah, that I understand.
Okay, so it will not be able to retrieve the data because my trigger or my lens got activated very small, minutely small time ahead of my data. Okay, my disk is rotating, right? This disk is rotating. So the lens has to activate at that instant where my data is exactly aligned. Okay, at this point, let's say this is the point from where it retrieves data. Okay. So if my data is at this point, then my lens can retrieve the data. If the data moves ahead, very small, very minutely ahead, even if it moves very minutely ahead, the lens will not be able to retrieve the data. That is the condition. Okay, and I'm sitting here. I'm sitting here. I've made the request for the lens to retrieve data. Okay, I'm sitting here, but I still cannot get data because lens is not retrieving any data. Now, how long will I need to wait? I will have to wait till the time this data takes the entire revolution and come back to that same point.
Okay.
Right, the lens once triggered is active, still active. So it is going the entire revolution. I'm not able to retrieve data, still not. Now I've reached here. At this instant, the lens started retrieving the data. Okay. So how long will I have to wait? Till the disk takes complete rotation. Right?
Right.
Is this clear?
Yes, this is clear. Yes.
Yeah. So I'll have to wait. So waiting means what? Latency, right? I'm asking for something and I had to wait for, let's say, 2 seconds to get the data. It will be by the latency of the system, whatever I'm working with. Okay. So if the data misses the lens, it will have to, the lens will have to wait for the disk to take entire rotation. That is the time I'll have to wait. So if you want to still understand this, you'll consider this analogy. Okay, this train thing. Okay, so this train is on the platform. Okay, it is right before 8. Okay, it's right before 8. This train leaves at 8. Okay, by any chance, if I miss the train and I reached on the platform by 8:02, that is 2 minutes after 8, the train has gone already. The train has left. I cannot board a moving train. Okay, and this train comes to the platform once in a day. So next time, if I want to board the same train, how long will I have to wait?
24 hours.
24 hours, right? So that 24 hours is the latency.
Understood. Finally understood. Yes.
Okay, so this, consider this, the lens as the passenger and the data is train. Okay, so if the data misses, you cannot board, so the lens cannot retrieve data. So how long will the lens have to wait for the data to come back to the same position?
Another one single rotation, and whatever time it takes, that is the latency.
That is the latency.
Okay.
Now there are two things, latency and worst case latency. Okay, why are we calling it worst case latency? Let's say my data was here. Okay, so let's say it is, again, we'll try to explain with the same example. If the train was at 8, okay, same time, I reached the station at 6 p.m. in the evening, not 8 a.m. in the morning, not 1 or 2 minutes late. I am already how many? 10 hours late. Okay, I'm already 10 hours late because I reached station at 6 p.m. in the evening. When does the train comes next time? 8 a.m. in the morning, right? So
Yes.
how much time do I have to wait? Complete 12 hours and plus 2. So I need to wait 14 hours,
Yes.
right? So 14 hours I have to wait, but it is still less than 24 hours. So my waiting
Okay.
time is less than 24 hours.
Okay. Correct.
Correct. So my latency is still 14 hours, but it is not the worst case because I did not have to wait 24 hours.
Oh. Okay.
Right.
Understood.
So if I just miss the train, my latency would be maximum.
Okay.
That is the reason. So now, if we come back to the exact example, if the lens just misses the data, the latency will be maximum. That is the reason we are calling it worst case latency.
All right.
Okay, so therefore we call it as worst case latency because we are just missing. That is the reason we are calculating the entire rotation. Okay, had the data been here, okay, if the question has been reframed as, okay, instead of worst case latency, by I said by the time the lens gets activated, the data has already moved half the rotation. How long will it take for the, or what will be the latency in that case? In that case, the lens will have to, so lens activated when my data was here, right? So the lens will have to wait only this, the time taken for the data to reach the half circle. So that will be my
Okay.
latency. But in any case, if I move, in any case, if I don't have to travel the entire rotation, my latency will not be worst case. It will be worst case latency only when I'll have to travel the entire, or I'll have to wait for the this to travel the entire rotation.
Okay.
Right? So that is why we call it latency. Sorry, worst case latency.
Understood that.
Is it clear now? So the question is clear now?
Yes. Yes, it is.
Okay, so the question is clear now. Now we'll get back to your actual question. That is why seconds per rotation is related to milliseconds. Okay, so in millisecond, this is what, this is the time. What is the worst case latency as per your understanding now? It is the time taken by this to complete one rotation. Okay, so we are interested in only this. Okay, and if if you give the denominator, if you still want to give the denominator, it is 1, and it therefore does not make any difference because rotation is 1. I'm calculating for one rotation. Okay, therefore the time taken for one rotation the time taken for one rotation, which is this, is this.
All right, got it.
Okay, fine. So probably this is clear now, right?
To me, it is, yes.
Okay, anyone else who did not understand anything about this? Any part of it? Yeah, so it is kind of a bit conceptual, right? We need to understand what is happening actually. That is the reason I gave this example of time. And we also need to understand that the later we come, the less is the latency. Okay, so when I just missed the train, it was 24 hours, and when I came in the evening at 8 p.m., it was only 14 hours. Similarly, if the data just misses, or the lens just misses the data, it will be the worst case. In any other case, it will not be the worst case. Still have to wait, but not as long as 8.33 milliseconds. Okay, so if I'll definitely provide this solution. I'm not sure how much this is clear in writing, whatever I've said, but I'll give this slides also. Okay, shall we move to next question? If there is no doubt in this.
Yes, we can. Yes.
Okay. All right. Again, a similar question I've taken from practice itself, but question worth knowing. Okay, so I'll give some time. Okay, so actually this question had options, but I'll just read out the options for you. Which function is better if you are sure that the input size n is always less than 10, right? So we need to find out if t1 is better, t2 is better, or both give same type of answer, same type of time, or both take same time, right? That is the thing. Okay, so I'm started getting the responses. Suyesh, what is it you want to ask?
The place where all the people are submitting the answers. I need
No,
to
no,
go
they
to
are
the.
just directly messaging me. So the
Oh,
way you have, yeah, they are simply directly messaging me.
all right, all right. Sorry.
Okay, so I've got many responses. Doesn't look like I have to wait for a long. Okay, so I've got sufficient answers, got 8 to 10 responses, and again, a better thing this time is the answer is only one. Okay, one as in there is no variation in the answer. Okay, and then maximum of you, all of you have said that T2 is the better function. Right, the T2 is better function for both. Okay, so I guess what you have done is put n equals to 10 here. Okay, so if you put n equals to 10 here, what will I get? 1200, 10,200 for T1, and then for n equals to 10 in the T2, what you will get? 1005, right? So I guess probably this is how you came up with the answer. Okay, so since all of you has given a right answer, can I get a response from any one of you? Explanation of this?
Yes, sir, but I used 9 instead of 10 here.
Use 9. Okay. Okay, so you were strict with always less than 10.
Yes, sir.
Okay, no issues.
So I used 9 in this equation. I got less number in T2. So it takes less seconds in T2 basically. So that's
Hmm.
why I did T2.
Got it. Yeah, got it. Okay, you try with 11.
But sir, like it says less than 10.
Yeah, but still you try with 11. Let me know what answer comes, okay? Okay, so apart from that, can anyone... Okay, so was this the only approach? Was this the approach for everyone? Put a number less than 10 and then find out which is smaller one. Probably yes. Just waiting for...
So I got the 11 answer.
okay.
Again, T2 is small. T2 is
Again, okay, so again T2 is smaller, right?
yes.
Okay, then why are we considering only less than 10?
In long time, T2 will be taking more time than T1.
Okay,
Yes, sir.
how long? Can you find that? Okay, so I've got a response in the chat. It says that the second function grows exponentially, but there is a threshold to that. Okay, below which the exponential function takes lesser time than the linear function with more massive coefficient. Okay. Okay, so Snail, you're saying this T2 is an exponential function, is it? Okay. Okay, so we need to understand that there is a difference between what exponential functions are and what polynomials are. Okay, so that is the reason I've taken this question, because okay, I need to say some one or two things, because there may be question which will not be as simple as putting the value and getting the answer. Okay, so probably if I'm not sure if you guys have access to quiz questions of previous term. you might find out a question which will not be solved, where you need to find out the range for which one function is better, right? So in that case, you cannot keep on adding numbers and wasting your time, right? And these calculations are easy. Therefore, what if I have things like logarithm? Okay. So for n greater than 100, they will start to catch up, I think. Okay, we'll see that. Okay, so I'll get start with the solution to this. So we need to first find out. Okay, yeah. So what is happening here is there are two search functions. Okay, the best way to solve this type of questions is to draw these functions mathematically. Okay, the best way to solve these functions is to draw them mathematically because it gives you more idea in that sense. Okay, so what I'll do is I'll simply try to draw this function. Okay, so my first function is t1 of n equals to 1000 n plus 200. Okay, how many of you know the equation of straight line?
Y
Okay,
equals
so
to
if
mx
I
plus c,
yes,
200 would be the like y.
correct, yeah. Okay, so this is, I'm explaining this for those who have a mathematical background, very good, you'll understand it very easily. For those who did not have, just try to understand what I'm saying here. Okay, so we are saying that, so if you forget about straight line and forget about what Rakesh has said now, y equals to mx plus c, just concentrate that if I have t1, so you forget about this bracket also, this is t, then there is 1000 plus 200. Okay, so this 200 is constant, right? No change in 200. But what happens is this t varies if n varies. Okay, so if I'm trying to vary this n, which is the number of inputs, the time taken by the function to converge or give the output is varying. Okay, so if you see that if you keep on increasing n, the t will increase. If you decrease n, the t will decrease. Okay, so you can call this that, you can say that the t and n for this function are varying linearly. Okay, now when you talk about a linear variation, it is linear, exactly linear straight line. Okay, so if I try to draw this function, okay, we'll go mathematically, I'll try to give some insights. Okay, if you can get it, it is okay. If you don't get it, there is a conventional way of putting the value 10 and answering the question. Okay, so here what is independently varying? N. Okay, because that depends on you how much to put. Okay, in this case we put 10, we can put 5 also, we could have put 15 also, right? So it is independent, depends on what we want. But the time is not independent. Did I say dependent? It is independent. Okay, but the time here is dependent on n. Okay, so if you whatever you put the value of n here, finally whatever comes up is something that you get as t. So it is an independent variable. That is the reason we put it in the y-axis. Okay, so if you understand the basic maths, we put independent variables on the x and dependent variables on the y. Okay, now what will be the time if n is equals to 0? Okay, so this n varies from here, and at this point both n and t are 0. Okay, both n and t at this point. Okay, now what will be the time, or what will be the value of time if n is 0? Right, so if I solve that, put n equals to 0 here, I'll get t equals to 200. What it says, t is 200 and n is 0. Okay, so this is that point where t equals to 200, because t varies vertically and n varies horizontally. Okay, and as I said before, that if n increases, the t will increase, so it will vary this way, linearly passing through this point. Why is it passing through this point? Because this is just a representation of n equals to 0. At every other point, let's say there is one point, let's say t equals to 10, sorry, n equals to 10. Here n is equals to 10. So for that, what is the corresponding t? It will be 1 0 2 0 0. right? 10,000 plus 200. Okay. So this point is 10, 1, 0, 2, 0, 0. This is how we mathematically represent a point on the graph. Okay, x coordinate, y coordinate. Is this part clear? Any doubt in this part? Did everything go above your head for this part? Whatever I said mathematically here?
Oh, sir, it's okay.
Okay, fine. So whatever things we did for this function, same thing we'll do for the other. Okay, that is n cube plus 5. Now how do I call it? N cube plus 5, right? So this I'll write here. Is n cube plus 5. So my time is varying with the factor of cube. With the factor of cube, not simply, not linearly. It is varying with cube. So minute change, a little change in time results in very large change in, sorry, a little change in the number of input will result into large change in the time taken by the function, right? Now this is cubic. Okay, so Snehil had given an answer that it is an exponential function. Okay, but there is a difference, right? So as I said, there is a difference between exponential functions and polynomial functions. Okay, so this is one of the polynomial function and we call it a cubic function. Okay, and if you see the trend of exponential function, you'll see that exponential functions are like this. Okay, this is, if this is t, this will be e to the power t. Note that the independent variable is in the power, whereas in cubic, the independent variable is not in the power, but it is in the base. Okay, so this is the difference. Okay, this part is clear. So this is not an exponential function, and there will not be any saturation to this function. Okay, what is saturation, by the way? What is saturation? What does saturation mean? Saturation is the function is increasing at some point it is going to same value. Okay, so if you keep on increasing time, see here, if you see, you increase the, so this is n, this is t, consider. So if you increase n, the time increases, but at one point, if you still increase n, there is no much change in the time. If you still increase n, there is no change in time. So we can say that our time function has saturated here. There is no change in the time, even if you change the number of n. So this will happen after this point. So we can say that the saturation has happened after this point. Okay, whereas, so this is not the case in exponential function. Okay, it will not saturate in any point of positive time. Okay, or positive number of inputs. Obviously, number of inputs cannot be negative, right? So therefore, it cannot go into go to saturation. All right. Now, what is the actual trend of then of the cubic function? Then let's go to that. Okay. So I have other question, but due to lack of space, I'll go to the next question, next page here. Okay. So this is a part of question number 3. Okay. So what is a cubic function? Okay. So if this is n, this is t2 of n. Okay, and if you see that, what was the cubic function? It was n cube plus 5, and here it is t. So again, if I put t n equals to 0, at n equals to 0, this, what do I get the value of t? I get it as 5. So it is somewhere here. Okay, it is somewhere here. Other than that, what will happen? It will move this way. Okay, so there will be a slight bend here wherever it is getting to t equals to, sorry, n equals to 0, and then it will again move ahead. Okay, so note that there is no saturation anywhere. Okay, no issues, Neil. All right, so this is the second function. Okay, and this is t equals to 5, and we'll again find out what is the value of t equals to 5 at n equals to 10. So it will be 10 cube plus 5, which will be 1005, right? 1005. Okay, so let's just write it here. This is n equals to 10. So if I track and trace the same value, I'll get this point. What is the coordinate of this point? 10 comma 1005. Okay, and now I will superimpose both the functions. Okay, both the functions I'll superimpose. Okay, so obviously these won't be exactly as per the points, but just we need to find out the trend, right? So what happens is, this was my linear function. Okay, was having some intercept here, and this was, I guess, 200, right? And then if I find out with respect to what 200 will come up, so I'll put it 5 here, then my other function would be like this, something like this. Okay, so if I go here, very sorry, just a minute. It will pass from this point and go this way. Okay, now if I keep on extending this, I'll see that there are around 3 points where they can coincide. Cannot. Okay, I'm assuming that they are. Okay, so what is actually what I'm doing? I'm trying to find out where these 2 points intersect. Okay, so how to find out that, leave it for now. But if you see this, okay, if you see this, you'll see that for this point, from this point to this point, let's name these points A, B, C. Okay, and then the linear one was T1 and the curved one is T2. Okay, and this is T and this is N. Okay, so if you compare both the functions between A and B, which one is taking less time? T1, and this is T2. Between B and C, which one is taking less time? T2. And after C, which one is taking less time? T1. Okay, so we can say that, so this will not be followed for entire range. Okay, so from this we understood that both the functions will have certain behavior in this range from A to C. Okay, that one will be better, the other will not be better, or vice versa, right? So we need to find out that range. If we need to see that range which is given in the question. Okay, and we are least bothered about n less than 0. Why? Because number of inputs cannot be less than 0, right? So we are bothered with the positive values of n. Okay, so we can say that starting with 0, my better function is T2 because it is taking less time comparatively. See, if there is this much difference. Okay, but there will be a point in time in future where the T2 will take more time than T1. Okay, it will take more time than T1, and then probably will keep on taking more time. Okay, they will never converge at same point. They will never come again back. Okay, because what does a cubic function say? It can intersect any function, any line only 3 times, not more than that. Depends on this. Okay, so we got 3 points, right? A, B, C point here. So before A and after C, there is no point of intersection for this function. One will be better than the other. Okay, so we just need to find this point. Okay, and we need to see whether this 10 is before this point or after this point. Okay, it can be easily seen from these values, right? Easily seen from these values. So if I draw a line here, a dotted line here, it will be somewhere 10. Okay, so what is this point? It is 1 0 0 5. And what is this point? It is 1 0 2 0 0. Okay, so 10 is given to understand. 10 is just given to make sure that only one function remains better, or one function performs better. Okay, that is the reason we are getting T2 as better for 9 also, for 10 also, and for 11 also. Because if this is 10, the 11 must stand somewhere here and 9 must stand somewhere here. Okay, what is the limit? This point is the limit. Okay, this point is the limit, n3. Okay, so just wanted to make sure if this is clear. Okay, that is the reason if when you guys took 10, you got better answer for T2, that is less time. And if I'm not wrong, Mehak, I've asked you to take it for 11. So for the very same reason you got for 11 also, you got T2 as better function. Okay.
Yes, sir.
Okay, now we need to find out what is the actual point after which T2 becomes a worse function or T1 becomes a better function. Okay, so if mathematically, if I see this, this is the point where both, so let's say, this is the point, right? So if I extend it on the y, this point on y or on t is same for both, right? This is where both the curves will give one value. This is the point where both the curves give one value. This is the point where both the curves give one value. What do I mean by one value? They are equal. These are the points where these two curves are equal. Other than that, either of them is greater. Okay, if T1 is greater, T2 will be small. If T2 is greater, T1 will be small. But these are the special points where both the functions are equal, that they give same performance. Okay, so questions can be framed in all these things, right? So and the question that is given to us now covers one of the scenarios of whatever I said. Okay, now if you are able to draw these curves, you will understand that number of questions can be asked. It can be asked that find out the number of inputs where both the functions perform equally. Okay, find out the range for which T2 performs better. Okay, so these can be now type of questions that can be framed on these type of concepts. Okay, so as I said, now if I move ahead, as I said, these three A, B, and C are the 3 points where both the functions are same. So what I need to do, I just need to equate their equation. Okay, so I need to equate 1000 n plus 200 to what? N cube plus 5. Okay, and how am I sure that I'll get 3 points? Because of this. So since it is a cubic equation and a cubic equation has 3 roots, okay, I'll get 3 such points where these 3 are, okay, these two curves are intersecting. Okay, so I've solved those 3 points. Just give me a minute. Okay, so one point is, so this C point, since it is a positive number, C point is 31.72. Point B is 0.19. So it is very close to origin. It doesn't look like, but it is very close to origin. And why is this happening? Because I've not drawn this function to scale. Okay. And what is point A? It is minus 31.5. And this is also minus, okay?
Yeah.
Minus 31.52. Yeah, anyone's saying something?
Oh, no, I was just correcting that B is equal to minus 0.195.
Yeah. This is also negative. That is the reason. See, I did not get the correct value, but I could say that it is a negative number.
Yeah.
Okay, so both A and B are negative, and C is positive. So now, what do I understand? What do I comprehend from this? I can say that 31.72 is the number of input I should give for both the functions to perform equally, give better same performance. Okay, so that is the reason for 11 also we had T2 better. For 12 also we'll get, this will follow till 31.72. Okay, so this was the idea of this question. Is this clear? Anything? So anything that I said uh, is not clear. I hope this was helpful. This question was helpful. Okay. Yeah. So just wanted to say Snehal that you were right for most of the part. It's just this what we say, the convergence and all, right? So cubic functions don't converge. Okay, and then again the thing that you said about nearly about 100. Okay, so that won't happen. Okay, after 31.72 there is no point in calculating a value where they will meet, because they won't. Okay, so if this is clear, shall I move to next question? No, okay, maybe I should. Okay, question number 4. It's part of graded question, I guess, week 7. Okay, so you are given an algorithm, okay, and then there are steps how that algorithm is formed. You don't need to do anything, don't need to calculate anything, just need to find out what will be the running complexity of this algorithm. Okay, I'll give options. So it is cubic, okay, quadratic, linear, exponential. Okay, note that all these three functions are polynomial and this function is exponential. Okay, so these are the 4 options. You need to find out what is the running complexity. Okay, so if I'll just give you intuition also, how do you understand when it is cubic or not? So if it is n cube, it is cubic. If it is n square, it is quadratic. If it is only n, it is linear. And exponential, see, exponential, the variable is in the power, so it is e to the power n. Okay, I've started getting the answers. I'll wait for probably 2 minutes. So this question is easier than it looks. Okay, just read the steps carefully and you'll get. Okay, should I go ahead? This simple question, if you understand the algorithm. Okay, so I'll go ahead. So before going details of this question, we need to understand that if I talk about n, okay, this is linear. Okay, so this n, this is not the answer of the question. Okay, I'm just saying if I'm talking about n, this is linear. Okay, if I say it is 2n, it is still linear. Okay, because coefficients don't matter. A constant coefficient will not matter. A constant coefficient. Okay, if it is n plus 100, okay, it is still linear. Okay, a constant intercept won't matter. Intercept as in shift. This is actually shifting. So what am I saying here is, see, if you go to this question, so this 200 shifted my curve upward, right? So the linear which should have gone this way has been moved up. Okay, so this is called as shift, and therefore this shift we also called it as intercept. Okay, so similarly, if this 100, if it is a constant, okay, then it will still be a linear. So these rules will hold for quadratic also, or cubic also, or exponential also. Okay, so it will be, if I write n square, 2n square, sorry, 2n square and n square plus 100. Why only 100? Can take any number. Okay, it is constant. So all these things, all these variations are also quadratic. Okay, so I've got a few number of responses. Some are saying cubic, some are saying quadratic. No one is up for exponential, no one is up for linear. Okay, so this linear I've just wrote to explain that the relation or the complexity will still hold if you multiply the number with a constant or add or subtract a constant from the number. Okay. Okay, so I will remove this part. Very tough to rub. Okay, so I'll go one by one. See what is happening. We have created a sorting algorithm. Sorting algorithm as in, so if I'm having, let's say, a set of 5 numbers, let's say 7, 1, 3, 2, 4. Okay, what does this algorithm do? It will sort them in the ascending and ascending order. Let's say ascending order. Okay, what order it sorts into, we'll see in the algorithm. Okay, so let's consider it is an ascending. So it will be, the final output will be 1, 2, 3, 4, and 7. Okay, so this is what is happening. So you pass these numbers to this algorithm and you get final output as this. Okay, so how is it doing this? It is searching through the list of numbers and to find the lowest number. Okay, so here we have taken 5 numbers. Note that this 5 is important. Okay, so we have taken 5 numbers. To search through and find out the lowest number, it will go to 7, then 1, then 3, then 2, then 4, then find out, okay, 1 is the smallest number. Okay, so how many visits it will have to do? So it depends on the number of numbers that we have given, right? Depends on the number of numbers. Here we have given 5. If we had given 6, it would have taken 6 comparisons. Okay, if we had given 8, it would have given 8 comparisons. So it depends on number. Okay, so here it will take n comparison. It will do n comparison to find out which one is the lowest. Okay, so here we know that for this particular task, searching through the list of numbers and finding the lowest number, the complexity is n. Okay, this part is clear. Okay, so I'll complete this. So to find out the lowest number from the list of n numbers, the complexity, or when we talk about complexity, it is worst case. Okay, it is worst case. So if you observe this list, you might find out that only in the second comparison one, I came to know that it may be the smallest. But how can I make sure that one is the smallest? By comparing it with the other numbers also, right? So I will have to go to other numbers. What if instead of 4 I had -1? Okay, what if instead of 4 I had -1? So I'm never sure, looking at a number, that this may be the smallest. Okay, so I'll have to do n comparisons there. Okay, so for this step, search to the list of numbers and find the lowest, and whatever it is. Okay, so I found the number lowest at position 1. Okay, so why is position 1? Let's write it again here. So it is 7, 1, 2, sorry, 3, just a minute, 3, 2, and 4. Okay, so this is 0, 1, 2, 3, and 4. And what is this 0, 1, 2, 3, 4? It is the index. Okay, index of the numbers. So at 0th position I have 7, at first position I have 1, at second position I have 3, and so on. Okay, so these are the indices. All right, so I went on and I saw that the lowest number, that is 1, is in the first position, that is first index, at index 1. Okay, so this index 1 is currently I. This is the I. Okay, so I have put, what does it say? Search through the list of numbers to find the lowest number and say its position is I. So whatever I found, it is in the index 1 and I have named it position as I. Okay, then move AI -1 to AI -2 to AI -1, and similar. Let's see what is happening. So what I'll do is, since I found, after n comparisons, I found out that my smallest number is at the index 1. Okay, so what I'll do, I'll remove this number. I'll remove this number and store it somewhere else whose index is I. And what is stored? 1. Okay, 1 is stored. Now, so if I'm removing this one, this place becomes vacant, right? So this place becomes vacant. That is what we are doing. So move AI -1 to AI. So this I -1, that is 0, 7, will move to AI, that is 1. Okay, you getting this? So what is happening now? So if should I go to next page? No, I'll not. Okay, so initially, once I found out that 1 is the smallest, it will be like this: 7, then space, then 3, then 2, then 4. Okay, 7, then space, then 3, then 2, then 4, and then I have 1 here separately written. Okay, and this is 0, 1, 2, 3, and 4, the indices. Then what I'll do, what does the algorithm say? It says that whatever is in the index just before that, or previous to that, all the indexes, all the numbers which are at the place before the lowest number, wherever you found that it is I, what you need to do, you need to keep on shifting them. Okay, what does it say? Move AI -1 to AI. So A0 will go to A1, A -1 will go to A0, A -2 will go to A -1, things, something like that. Okay, so that will be the movement. Okay, and then now once I do this, when this 7 goes from 0 to 1, what will happen? I'll have a list like this: space, then 7, 3, 2, and 4. Okay, so this is 0, this is 1, 2, 3, and 4. Then what does it say? Place the original AI in the position 0. So original AI, what is the original AI? That is 1, so put 1 here. So what did it do? With this movement, I'm able to bring my lowest number to the first point. Okay, I am able to make my lowest number to the first point. You got it? So what happened here? At after n sorting, just finding out what we are doing now, this position, now these thing gets on repeating, right? What it says, repeat the above steps. Okay, so what happened? Find out the lowest number, okay, move it to the first position, and then keep on shifting the others number to that position itself. Okay, that is how you keep on making the numbers in the ascending order. Okay, now for doing that, what will happen? You will have to search through n numbers first, so that complexity becomes n. Now what I'll do, I'll repeat the same procedure, but I'll not take this into account because I've already put the lowest number in the first position. Okay, so I'll do this with how many numbers? N minus 1. Okay, so n minus 1 numbers, I'll have to do the same procedure. When the number was n, how much time, what was the complexity? N. Okay, when the numbers are n minus 1, what will be the complexity? N. Why is that? Because it comes in the category of the last thing which I said, right? N plus 1000. It is simply shifting, but the complexity remains n, not n minus 1. Okay, so you do this n. Okay, first n times, then n times. Okay, now after sorting, what will happen? This 1, then 2, then what will happen? It will be 7, then 3, then 4. I hope how you got this 1, 2, 7, 3, 4. I did the same steps. Okay, I moved on with 7, 3, 2, 4, found out that 2 is the smallest, shifted, removed 2, and then shifted 3 to 2, 7 to 3, and put 2 back to the lowest position. Okay, do not consider this. We are looking at this. Okay, so this number will, this same procedure will make the number 2 to come in the second position, which is first position for n minus 1 numbers. Okay, right? So for that also my complexity is n. Okay, and then I'll do it for 3 other values with n minus 1, n minus 2, n minus 3, n minus 4, right? How many times I'll have to do the conversion? How many times I'll have to search through? What will be the complexity? N, n, n. Okay, so this n got multiplied to 5 times. Okay, this n got multiplied 5 times. What is 5? I said to remember this number, right? What is 5? It is nothing but n. So what is actually happening? We are doing this n times. Okay, so that is the reason we are having n complexity n times. Okay, and n complexity n times. So here it is not adding a constant, it is not multiplied with a constant number, it is now multiplied with the again a variable. So n multiplied by n is not equals to a constant, that is k multiplied by n. So here the complexity will not remain n, but it will become n, that is n square. Okay, so this sorting algorithm will have the complexity of n square, and with n square I'll say that the complexity is quadratic. Is this part clear? Any confusion? Anyone speaking?
Sir, this is basically sort, right?
Yeah, it is sort. It is a simple sorting algorithm. Just need to find out what is the complexity of algorithm with the steps it is following. Okay, so basically what I did is simply followed what the algorithm is doing and then found out, okay. But knowing that a constant subtractor added to the number of inputs or the n will not affect its complexity. Okay, that is the reason instead of putting n minus 1, I put n minus 2, I put n. And how many times I had to repeat that? N times. So doing something of complexity n times will make it quadratic.
I didn't understand why didn't you take n minus 2 and n minus 2? Why did you take n to multiply?
Yeah, see, because n minus 3, right? So you had 4, initially you had 5 numbers. Okay, then you had 4 numbers. 4 numbers is actually the n numbers, because you have done same n calculations, right? So when you had five numbers in your in the list, you had to do it n times. Okay, 5 times. When you had 4 numbers in the list, how many times you had to do it? 4 times. Okay. When you had 3 numbers, how many times you had to do it? 3 times. Okay. So it depends on the numbers, how many numbers that are there in the list. Okay, but as I said, this thing, okay, I've written it here only, right? So as I said, when the numbers are subtracted or added, when a constant is subtracted or added to a number, when a constant is multiplied or divided from the number, the complexity does not change. Okay, the complexity will not change here. The complexity of n remains n, because see, so if you see this figure, this is 1000n plus 200. Okay, this line, what is this line? 1000n only, it will be 1000n. But the trend, if you see, both are parallel, right? Both are same line, just shifted, right? Therefore therefore I'll say that both are linear. With this, did the constant have any effect on the lines? No, it did not have any effect on the line, it just shifted, and shifting will not make any change in the complexity. Okay, in the complexity, shifting will not make any change. Okay, this is selection sort. I'm not very sure about the name, so I don't want to comment on that. Okay, so there are various sorting method, but I'm not very sure about this name. Okay. Okay, so are you clear that why are we taking n?
Yes, sir.
See, it's very hard to digest that why it is not n minus 1, because we are not calculating the number of steps. You need to understand that if I said, okay, how many steps it will take, then it will be, then subtracting a number would be important to you. We are finding out complexity. Okay, complexity doesn't have anything to do with the subtraction or the constant numbers that are adding or subtracted. It has to do with the input. Okay, so when you had 4 numbers, your entire mechanism was, or entire sorting mechanism was based on those 4 numbers. Okay, so depending on those numbers, you had those many comparisons. Okay, so calculating comparison, calculating what we say number of steps, that is okay. That in that case we would have considered n minus 1, n minus 2, n minus 3. Okay, but in complexity, if it is linear, it is linear. Coefficient or intercept will not make any difference. Is this clear? Hello.
Yes, sir.
Yes, sir.
Okay, now if you are still not clear, let me give you another way of doing it. Okay, so how many times, what was the number of inputs it took initially for the very first time? N. Okay, and then in the first method, what I did? N. Okay, I took 5 times n, right? Why is this 5? N. So I got n into n into, sorry, n plus n plus n plus n, n into n. Okay, this is clear. Now we'll go with what you are saying. So initially it will take n, then it will take n minus 1, then it will take n minus 2, then it will take n minus 3, then it will take n minus 4. Okay, is it right? So how many are these? N. Now you add these. How many? What you will get? What you will get? You will get 5n minus I guess 10. Is it minus 3 minus 6? Yes, you will get 5n minus 10. Okay, 5n minus 10. Now, this 5n minus 10, what is this 5? What is this 5?
N.
N, right? So you can write it as n square minus 10. Right? So if it is n square minus 10, will this 10 have any effect on this n square? Will this 10 change the complexity of n square to linear or quadratic or cubic? Does that have the power to make this quadratic or cubic or linear?
No, sir.
No, right? So in that case also you will get quadratic only. Okay, so either you neglect the coefficient, neglect the intercept and coefficient from the very beginning, or you keep them and then neglect the coefficient or constant at the later. Just you need to make sure that this is not a constant. This depends on if I had n minus 5 here, it would have been 6n minus whatever 15. Okay, 6n minus 15. In that case, it would be again 6. Depends on how many inputs we are having, right? So it is again n. It is not a constant. So it is n square minus 15. Then you neglect this 15. It is still a quadratic. Is it clear now? A bit clear?
Yes,
Or did
sir.
I confuse you more? So you go through it, whatever I've said, this is like live streaming, right? So whatever I've said, you will be able to hear it once again on the YouTube. So go through it, what I'm saying, okay, right from the beginning, and you'll understand. All right. So if there is no doubt in this question, we'll move to the last question, okay? And I think it might not take to solve the last question because we have taken this question yesterday in the last session. Okay. So I'll wait for 2 minutes again, and then we'll discuss this. Okay, I've got just one response, although I've taken this question in the previous session also. Okay, I'll just wait for 1 more minute because I guess there is another session right now, right, at 4. Okay, no issues, Snail. You will be able to watch this video again, right, on YouTube. Okay, so yeah, those who have session, I'll not ask you to leave right now. I'll just take 2 minutes of your time and then you can move to that session. Okay. Okay, so the answer here is pretty straightforward. Okay, so and since I have explained this question in the last session also, I'll be a bit quicker here in this session. Okay, and for this question, just wanted to take this question so that you understand all types of numericals that are there. Okay, so I'll move ahead. Okay, so I had only two responses, by the way, but the answer would be from the responses 125. What is the unit, by the way?
125 requests per second.
Okay, so 125 requests per second. Okay, so this is the answer that I've got from the chat. All right, so see what is happening here. A server has a 16 core, so the certain specification of a server is given. Okay, it is a 16 core CPU, 64 GB RAM, and 1 Gbps network connection. Okay, so it is 64 GB RAM and 1 Gbps network connection. Okay, so where will I use this 16 core? I'll use this 16 core, this information 16 core CPU, where certain question is asked on the performance as in how many tasks it can do simultaneously. Okay, it can by itself do simultaneously. So that is where core comes into picture. I'm I'm not sure if you'll be seeing question on this part. Okay, the second part is 64 GB RAM. It depends. So 64 GB RAM gives you an information of how much data, or data as in how large files it can process simultaneously on the run. Okay, simultaneously on the run, that is concurrently give. Okay, what is the amount of data it can concurrently show to all. Okay, for example, when we talk about YouTube streaming, okay, so there are multiple viewers of the same video. Okay, so if this server, if the video is stored on this server and there are, let's say, 100 viewers of the video, it will have to show this video to 100 users or 100 viewers simultaneously, right? For that, so this video is being played or is being processed by the RAM and then sent to every viewer. Okay, so it depends on the size of RAM, how large videos can be or large files can be is concurrently sent. Okay, and the last thing we have is 1 Gbps network connection. 1 Gbps network connection is the bandwidth. So what is bandwidth saying? Bandwidth gives the information of how many pages it can render or how much information it can send per second. It can send per second. See, 64 GB RAM. RAM is how much information it can process concurrently. Okay, at that point. And network bandwidth gives the information of how much info or how much data it can send per second. Okay, so there is a difference. Then there is a Python Flask application. Okay, so with this connection, I'm running a Python Flask application, and that Flask application also has a rate by which it generates HTML pages. Okay, so with that application, you are able to generate 500 HTML pages per second. Okay, and as in additional information on the page is that, and this is not an additional information, by the way, an information on the page is that it has a 1 MB image. It is having a 1 MB image that needs to be downloaded by the client every time. Okay, I'm loading all those pages. Okay, so if these 500 pages will have 1 MB images, okay, and that will be rendered by the browser. Okay, so I need to find out with this network bandwidth, how many such pages I can send per second. Okay, how many such pages I can send per second. So what I have to find out, what is bandwidth actually? It is size of request or size of HTML page or size of info whatever information is there. Okay, so bandwidth is size of information, okay, into number of such information, number of such request HTML pages info. Okay, so if I see I have this, okay, and I have this, and I need to find this, right? So I have bandwidth that is 1 Gbps, 1 Gbps. If I'm, so I guess all of you are now familiar with conversions. So I'll simply write 1 into 10 raised to power 9 bits per second. Okay. And size of each image. See here, this HTML is having one page. So I'm assuming it is it is imperative to assume that the size of that page is equals to size of the image. Why is that? See, if I'm writing an HTML page, okay, without the image, what should be the size? It will be in some kbs, kilobytes, or even bytes. Okay, and when I'm talking about an image, it is in megabyte. Okay, so altogether my HTML will be a combination of that image, which is 1 megabyte, plus the information, other information, that is the text and all the tags and all, that is in the kilobytes. Okay, and this image, this megabyte, is significantly larger than kilobyte. Okay, and for most cases this will be bytes, not even kilobytes. Okay, so it is significantly large. So I can assume that the size of my HTML page is 1 megabyte. Okay, it is safe to assume that. Okay, so here the size of request HTML info I can simply write as 1 megabyte. So it is 1 mega, right? So it is 1 into 10 raised to power 6. Okay, and then we are talking about bytes here. Capital B means bytes. This means if I want to convert it into bits, it will be 8. Okay, so it is 1 into 10 raised to power 9, that is bandwidth, size of image or request or HTML page, and then I just wanted to find number of such requests, which is, let's say it is n. Okay, so if I solve this, what I'll get 1 by 8 into 10 raised to power 3, right? So this 6 goes 3 and then 8 goes here. What is this? It is 0.125 into 10 raised to power 3, which is 125. Okay, so 125 of such request can be sent with the given network bandwidth. Okay, now one thing to look at here is we are using this network bandwidth and we are using this. If we are getting answer by using both of these, what is the purpose of having this? Okay, it can run Python Flask application that can generate 500 HTML pages per second. It can generate, my application can generate 500 HTML pages. Application that is at the server side, it can generate 500 HTML pages. But can a client get 500 HTML pages per second? No. Why? Because it is limited by the bandwidth. Okay, so there are two things. One is bandwidth, and second is the rate of Flask app, right? So there are two parameters deciding what is the number of requests or maximum number of requests per second that the server can handle. Okay, and then we have to take care of every parameter, right? Every parameter is contributing, so we need to take care of every parameter. And then if a parameter is slowing down the system, the entire system will slow down because of that parameter. Okay, so even though my Flask application is able to create 500 HTML pages, what will it do by creating those pages if they are not able to, if they are not being able to send only? Okay, if they are not able to go to the client, what is the purpose? What is the use of having this? Okay, so finally as in at the net output, what do I get? 125, which is decided by the slower one. So whatever is the slower, finally answer will be decided by that. Okay, had this 500 HTML pages, had this rate been 100, okay, it can run Python Flask application that can generate only 100 HTML pages. In that case, even though my network bandwidth is allowing me to do 125 pages request, I can process only 100. In that case, the answer would be 100. So this is where we make use of this factor. Okay, here 500 is safely larger than 125. So therefore it looks like there is no role of this 500 HTML pages, but actually it plays. Okay, so I guess with this, I've also given you a very, answer like hint for other questions of graded, but that is okay. All right, if this part is clear, right? This question is clear. I've taken
So
it.
can I ask? Sir, can I ask something like, would it make any difference if the RAM was 64 MB instead of 64 GB?
It wouldn't have.
So basically, serving the pages does not have any effect on RAM. Only like just like rendering a video, playing a video requires RAM, but serving an image does not require like put load on RAM.
See, static data. See, this is server.
Mm-hmm.
Okay, this is your RAM, and this is the client. Okay, so and this is the piece of information. Okay, so this is, let's say, my pages, and this is the video. Okay, with V. Okay, so what is happening? This page is at once going. So if you're having 64 GB RAM, this RAM is able to process 1 MB page, right? And it is not even processing, it is simply sending. Who is processing that HTML data?
Like the receiver,
The browser, the client, right?
probably, yeah.
You don't have to worry about what RAM it is, but the video, it is processed because it is going each and every second till the duration the video lasts. Okay, so the piece of information, that HTML page, is simply getting sent, but the video is getting processed and shown to the browser client. It is actually being played here, and then whatever is being played here is what you see at the client side. Getting? So there is a difference between the type of data. The video is concurrently as in it is in what we say, it is continuously being coming. Okay, if the video is 5 minutes, it is a 5-minute long video. A 5-minute long video is coming each and every second till the 5 minutes. Okay, but here we are simply writing about rates, right? Bandwidth, 1 second, okay, 125. Within 1 second, 125 pages will be served. That's it. Okay, so RAM is what you work with here, and bandwidth is what you work with here, how your connection is.
So basically, if you want to like, even if we increase the request by an order of magnitude, we would not need to like increase the RAM, only increasing the bandwidth or the like number of pages generated per second. That would be need. That would
Yeah,
be need to
see, your RAM is 64 GB, and what is the size of page?
No, I mean, like, if it would have been like in MBs, RAM, if the RAM would have been MBs, then also it would not have been a problem.
In that case, yeah, so even in MB, see, 64 MB is a very small RAM, right? It's very small RAM. So it might throw some issues with pages also, because you are having 125 MB of data going per second.
Yeah, that is why I was asking it, like, because in GBs it wouldn't make a difference, but when it's like once the 125 MB is going and the RAM is like very smaller than that, then like there might be problem. Let's say it has some space. Let's say our Flask app requires only like certain, like you say, let's say 10 MB of RAM to run the Flask application.
Yes.
So the Flask application would be able to run fully, but would it be able to serve that much request? Since the request like want like that much data. That was exactly my question.
Okay, got it. Yeah, so maybe would have been a problem. Why? Because if your Flask application is using 10 MB, okay, so it is having a balance of 54 MB. Okay,
Yeah. Yes, sir.
54 MB, and but your actual data is
125
125 of
MB.
MB. Yeah. So
Yes,
in
sir.
that case, what will happen? There will be certain. So what is happening here? It will process 54 MB of data and then process it, and then again it will send the remaining data and then again process it and send.
So technically, it
Okay.
would not be able to send 125 images in a second. It would only be able to send 54 in
Yeah.
a
So we
second.
cannot. Yeah, but the thing is, see, the point is it really processing the data?
Not exactly. Yeah, it's
Right?
not processing the data. Yeah. Yes.
Yeah. So it is getting, see, the data retrieved by the server from the database sent to the client. There is no role of RAM, right?
Yes, sir.
So that if, but the video is getting played at the server. That is why we need a RAM. Where exactly will you bring the video for it to play?
Yeah.
On the RAM. But
Yeah.
this HTML or this data of 125 MB or 125 requests, whatever, all these requests are directly coming from database and going to the server. Sorry, client. No
So can we
processing
try
there.
it? Can we try it practically? Like as in probably I can try it on Azure and we'll ask about it like later on, I guess.
Okay,
Like
okay.
I'll try something like this. Basically, I'll host an API on Azure and we'll probably try to replicate what this thing is doing.
Okay, with the 64 MB RAM.
No, 64 MB is not possible on the Azure, I guess.
That's what.
Like
Yeah.
whatever would be the minimum possible specifications there.
It will definitely, I think it will affect. Why? Because see, even if you are loading, now leave it, leave there if there is a video. Forget about
Mm-hmm.
video. Even if
Yeah.
if the site is very heavy, it is having more dynamic content. It takes time, right?
Yes, sir.
So it will affect.
No,
So
let's say it's an API.
uh-huh.
Then there is no case about any other stuff. Only the image link or something like that. Like image could be
Okay.
passed.
Yeah. Okay. See, there are a number
Mm.
of things, right? This is a simple question talking about client and server.
Yeah.
Yeah. So what is important here is to understand that. So these are all that is the reason a server is having these many parameters, right? What to use when
Mm-hmm.
is dependent on us. The 16 core CPU and 64 GB RAM are way more than what we generally require for this thing.
Yeah.
Okay,
I
they
just
are
wanted
just
to know
given.
basically. I just wanted to know if static content has any effect on RAM as well, or it doesn't.
Okay, yeah.
Yes.
All right, yeah.
Thank you, sir.
So if by any chance this app, so consider this to be the client side rendering because it is only simply HTML. Okay, so we talk about server side rendering. In that case, you'll need RAM.
Okay, sir.
Right? So it depends on where the rendering is happening.
Okay.
Okay, if simply see, if you consider you have a room filled with articles, okay, things, objects, okay, and you are the RAM. Okay, and if there are two scenarios, one scenario is just give me whatever you get. Okay, and second scenario is open and see if it is relevant to me, give it to me.
Yeah,
Can you
the
get the
second one
two?
would obviously yes, sir.
So the second one is where you're using RAM. The first one is where you're
Mm.
simply serving the data.
Yes, sir.
Yeah, so it depends.
Okay, sir. Thank you,
If
sir.
by any chance I'm saying in the first case also, just let me know what is their name of the article. Some minor processing you need to do. So some
Yeah, very
RAM will
minor
be
processing
needed.
would be there. Yeah.
Yeah, so that is the idea. Some if RAM is required, it is required. Then it will affect the speed.
Okay, sir.
Okay, so okay, that was one way of looking at it. All right, so I guess this is clear, right? All the questions are clear. I had planned 5 questions. I'll send you this file, okay? Probably a detailed solution one, but I hope this part is clear. So these are the type of numericals that we might ask, and if there are the numericals that we might ask will be a build up on this, okay, using the same concepts, but a build up on this. Okay, cannot ask directly the same, okay, changing values, that won't happen. All right. So with this, I would call this as the end of the session. Okay. If there are any doubt, please you can ask. Otherwise, we can call it a day. I hope this session was helpful. Okay. Somebody raised hand. Bhavya. Yes.
Sir, how will you be sharing this file with us?
I'll put it on this discourse. Okay.
All right, sir.
Okay, so for the week one also I did the same. What I did
Yeah.
was I gave a printed solution for this, and let's see how can I. So there are numerous things that I've said. Let me see how much of those I can put as a printed part, and then I'll put this file as a file in the discourse.
All right, sir. Thank you.
Okay. Okay. So if there is nothing else, shall we close the session? Okay, probably I think we can. Okay, so thank you everyone. Thanks for joining. We'll close the session.